Welcome back. In today's lesson for periodic table, we're going to be talking valence electrons. Now, I know that we've discussed what valence electrons are already, which is that valence electrons are the outermost shell of an electron configuration. So, for instance, in the case of sodium, which has an electron configuration of 2, 8, 1, the valence electrons are always in this last shell, right? So sodium has 1 valence electron. Now that's prior knowledge that you need in order for us to continue and apply valence electrons to the periodic table. So the first thing that we need to understand is that valence electrons determine an atom's chemical properties. So any of the chemical properties, combustion, zero chemical properties, and melting points, boiling points are physical properties, but the way elements react, how they react is all determined by the valence electrons within that atom. It happens to be that if elements have the same number of valence electrons, they're going to behave similarly as it relates to their chemical properties. Okay, now this goes for anything. So if I use beryllium as an example, beryllium having a electron configuration of 2-2, then anything also having 2 valence electrons will behave similarly. So calcium, for instance, it might have a bigger electron configuration, 2, 8, 8, 2, but the fact that the final number left in each of these configurations is 2 leads us to the understanding that they are going to have the same or similar chemical properties. All right, this is a very, very important part. This is the main part of this lesson. So what I want you to do is take a look at the periodic table. Now we're going to be using the New York State Chemistry Regents periodic table, and we're going to see if we can come to a conclusion about elements that are in the same group as one another. Now we're going to only be looking at 1 and 2, or we're going to be looking through 13 and 18. We're not going to be looking at groups 3 to 12 because they do something different. So we're just going to look at the 2 main pillars on either side of the periodic table. What might indicate that they have similar chemical properties? So if we go and we look here, what we will be able to see is, we'll look at group 2, for instance. We'll take a look at group 2. And the thing that we notice about every single thing in group 2 is, let's zoom in a little. Well, that didn't work. We'll zoom in a little. Maybe we won't. We can't just touch anything, so we'll just leave it as is. What we can see is there are 2 valence electrons in Be, 2 in magnesium, 2 in calcium, 2 in strontium, 2 in barium, 2 in radium. And all of these elements are in the same group because they have the same valence electrons. And because they have the same valence electrons, they have similar or the same chemical properties. The same can be said for any group 1, 2, or 13 through 18. We can just take a gander over here at group 17. And what we see here in group 17 is a similar thing. It's just the only difference is that number at the end is no longer 2, but now it's 7. And they are still all the same as one another. So all of these in group 17 have similar chemical properties. So we'll go back for a second and we'll take a look at the rest of our notes that we have waiting for us. No, I don't want to save. All right, so what do we notice about things that are in the same group? We notice that they have the same valence electrons. And because they have the same valence electrons, they are going to have the same or similar chemical properties. All right? So a little bit along the lines of valence electrons, but a little bit different, is we talked about elements gaining or losing electrons to become stable. So this is when ions are formed. In the case of an ion that comes from an atom, we are either gaining or losing electrons. Now, we're going to look at it a little differently. Instead of being told what happens, we can kind of take a guess. Now, an element is not stable, right? An element is not stable, or most elements are not necessarily stable. They need to become ions. And in order to do so, they have to take their whole final energy level and fill or empty it, right? We want to fill or empty the last shell. Usually this means that we want 8 valence electrons. Normally, in this case, we say that 8 is great. It's an easy way to remember that a full valence shell is 8 electrons. It technically is called an octet, okay? Because an octet meaning 8 valence electrons. On occasion, however, sometimes it can mean 2 valence electrons. When does it mean 2 valence electrons? When will 2 valence electrons form a stable atom? It will form a stable atom with only the first shell. Okay. Only the first shell can have 2 valence electrons to be complete. In the case of helium, we look at helium, and it only has 2 valence electrons. Since the first shell only holds 2 valence electrons, it will be filled just like that. Outside of hydrogen, helium, lithium, beryllium, everything else is going to need to get 8 valence electrons. So what we're going to start doing is determining if elements are going to gain or going to lose. All right. Thank you so much for watching. We'll continue this lesson on the next day. I hope you learned and loved learning about all of these valence electrons and octets.